Then we will move on with Parkwind's roadmap from Timothée PIRE.
Hello, everyone. I'm Timothée PIRE, and I'm working in Parkwind as a structural engineer. Parkwind is a developer and owner of offshore wind farms, so now we'll discuss a bit the roadmap for another application, which is offshore wind farms. First of all, I would like to have a quick description of how a foundation looks like. So here I've chosen the most commonly used foundation type, which is the monopile. So basically you have the monopile, which is driven into the soil. On top of that, we have the transition piece, which is the part in yellow, and then the tower. And on top of the whole thing, we have the nacelle and the 3 blades. Obviously, it's a structural and mechanical system, so we need to be able to perform some operation and maintenance on that structure, so we need to have access to it. This means that in design, we include some access ladders, which is connected to the transition piece. And we also have the external platform, which is required to perform some works or to make some exchange of components on the foundation. As an owner of offshore wind farm, the main goal for us is to make design choices that reduces the requirement for operation and maintenance during the full lifetime of the foundation. This is for 2 main reasons. First of all, every time you send people offshore, there is always a risk. And every O&M operation is also related to a high cost. So yeah, we look for a reduction of O&M operation as much as we can. On the other side, the material that is commonly used for such structures is steel, which, as you all know, is subjected to corrosion. So we need a lot of systems to protect the steel. And in the atmospheric zone, the only thing that can be used is considering coating. All in all, we can see that there is a big benefit in replacing the steel by the composite so that we eliminate for those components the corrosion. And if there is no corrosion, there is no need of O&M operations to repair the coating. Also, we look for systems which reduce the use of mechanical fasteners, such as bolts, because bolts, we also need to have people on site checking the torque of the bolts on a regular basis. So basically, the main idea of Parkwind and why this is why we joined this project was to replace the external platform, which is currently made out of steel, as you can see on the left picture, and replace it by a composite external platform. So the reasons, as I already explained, is to reduce the corrosion in case, for example, of a dropped object. If we have a coated steel platform, you can make some damage to the paint, while in case of a composite platform, you just make a dent in the platform, but there is not much harm done. So the benefit is direct on that aspect. You can see on the left, basically, that the platform is directly welded onto the transition piece, which also creates some significant stress concentration factors on the transition piece and requires to have some thicker plates to fabricate the transition piece. On the right side, you see the current concept that we have. So we have the composite platform, which is connected to a ring beam via adhesive, but we also use a bolt to take vertical forces from bottom to top, which can occur during wave run-ups. I will come back on that aspect later on. In terms of roadmap, there are four main steps in our case. So first of all, we need to identify the suitable projects to use the composite external platform. Then we need to make the design, get the certification, and finally fabricate, install, monitor, and make the whole maintenance of that platform. Let's go through all of those steps one by one. So first of all, what is a suitable project to use a composite external platform? Technically, all of them. There are no restrictions in terms of weather, in terms of temperature, and so on. So basically, we could use that kind of concept for any kind of project. However, we have some potential hurdles from project to project, which could be, for example, the local regulations. So there are some countries in which it's definitely more difficult than in others to come with innovative ideas, or there are a lot of steps to fulfill before you can get certification from the local authorities. There are also some potential interfaces with other parties or other design choices which may prevent from using composite materials. So it's always design choices that you need to make at the beginning of a project to identify the potential benefit of using composite secondary steel. And then finally, there is obviously the availability of companies able to manufacture such composite platforms. Then we come to the design, and obviously here in Qualify, a lot of work has been done, which is definitely beneficial for the design of our case. So definitely when we'll come to the design in a concrete project, we will use all the results and use the Qualify guidelines. Still, in terms of design, we still have some challenges. So maybe the first one, it's the connection to the primary steel. As you can see on the right sketch, you can see it's a bit complex with still some welding, some adhesive, some bolts to maintain the whole thing. So today it's the solution at which we are, but we are still looking for improvement to simplify this kind of connection. Then it's a bit out of the scope of Qualify because the significant loads is something that is more related to the composite platform itself rather than on the connection. So I mentioned here 25 tons. It's the load that we may experience on the platform when we make the exchange of some main electrical components of the turbine. Then we have the uplift forces, as you can see on the top picture. This is the famous wave run-up that I discussed earlier, which can create massive loads from bottom to top, and for which we need to have a resistant connection. Finally, a topic that was already discussed by previous of my colleagues, it's the resistance to fire. So we need to make a design that allows workers that would be on the turbine to make the evacuation in a safe way. So this is still something that we are looking at to perform such a design. Once the design is finalized, obviously we need to get the certification to be allowed to fabricate and install it. So this is all the benefit of having Bureau Veritas and Lloyd Register in this project, so that those two parties are already aware and deeply involved in this project, and yeah, know how to make the certification of such connection. Finally, we arrive to the step where all of that stuff comes to life. So there is the challenge of fabricating such a big piece. As you can see, some dimensions on the left. To to be mentioned that those are the dimensions of the turbine that are today available on the market. But as you may know, the turbines are growing really quickly, and so the size of the external platform will increase in size as well. So we all expect that in the near future, those external platforms will get bigger and bigger as well. In terms of installation, monitoring, and maintenance, obviously, we would have a deep look into the behavior of the adhesive by adding some sensors and checking how it behaves throughout the lifetime of the wind turbine, which is, depending on projects, about 25 years. And then looking at really long-term improvements of the joint, we would like to, as a simplification of the joint that I presented you previously, get to a solution where we connect the composite platform directly to the steel of the transition piece via adhesive. So in that case, this would definitely reduce the all the weld. This would thus reduce the stress concentration factors on the transition piece, and reduce all the complexity of the connection of the external platform to the transition piece. Thank you all for your attention, and I will be more than welcome to answer your questions.
Thank you very much, Timothée. That was great. Do we have any questions? Yeah. People are applauding. Yes, please.
Hi. First of all, very interesting outlook towards what is happening, what we can expect in the future. Now also with that one, I have the question with the transition piece. So you were looking quite detailed into the connection between the transition piece and the composite itself. Do you see also the potential of changing the transition piece in order to have maybe a bit bigger surface area for the bonding that then also increases the strength of that connection? Is that also a potential solution, or are you fixed to that transition piece, how it is at the moment?
Definitely, we can look to any kind of solution. What I would say is that the transition piece, now as it's fabricated, is made out of flat plates that are rolled and welded together. So it makes kind of a smooth fabrication process. If we had to change the full concept of the transition piece, then we would need to investigate what are the consequences in terms of fabrication and see where the benefit is.
Right. I see. Thank you.
Thank you, Timothée.
Thank you.